So here we go with lesson 2.4 of our quadratic units, number 2. And I want to just recap a little bit. So what we've been doing is trying to learn how to graph quadratic functions and define their characteristics. Remember, in one of our first lessons, we were looking at the function that's typically written as ax² plus bx plus c. And this is known as standard form. And so we first learned then the very beginning, our parent function, the basic function of y equals x², and what that looks like and some key characteristics of that. Then in the last lesson, we introduced the a in front of the x². And depending on this coefficient, we might have a parabola that's stretched vertically or compressed vertically or flipped upside down. So that a value really changed our basic parent function of y equals x². Well, now in lesson 2.4, we're going to add the c value of our standard form. So we're going to take a look at graphs of y equals ax², but now we're adding c. And we'll see how c changes our parabola. So here, the graph of y equals x² plus c, this is a vertical translation up c units. That is if c is greater than 0. Now, if c is less than 0, this is a vertical translation of the parent function, but this is down c units. And the vertex of y equals ax² plus c is the coordinates 0, c, whatever number is in that c position. And the axis of symmetry still coincides with the x term of the coordinate. So let's take a look at the parent function. Hopefully we recognize this is our parent function. We have some key points on our parent function. We have our vertex here, and then we have our first couple of points, 1, 1, 2, 4, and that's our step. So that is our parent function. And now in the first example here, let's use a table of values to fill in this function's tables. So this is y equals x² minus 2. So let's go ahead and start with our substitution. We are going to use these x values given here. So y equals, let's put -2 in, we square it, minus 2, and that's 4 minus 2, so that equals 2. Next, we'll do y equals -1 squared minus 2, and that equals -1. And then y equals 0 squared minus 2, and that'll equal -2. And then y equals 1 squared minus 2, and that'll equal -1. And then y equals 2 squared minus 2, and that'll equal 2. So let's go over to our graph, zoom in a little bit, and plot our points. So we have -2, 2, -2 right up here. We have -1, -1. We have 0, -2, 1, -1, and then 2, 2. So we have the shape of our parabola here. Okay. And we can see a couple of things. So we have here the point at which the parabola changes, and that is the vertex. And here it looks like it is at 0, -2. And then we also see the axis of symmetry. As stated above, it's still 0. So let's go ahead and fill in some of the information on the next. So the axis of symmetry was x equals 0. The vertex was 0, -2. And the x-intercept, or where the parabola touched the x-axis, was at x equals 0. So now we want to use a sentence to describe the difference between this quadratic relation and the parent function. So what is the difference between y equals x squared minus 2 and y equals x squared? So basically, it is shifted down 2 units on the graph. Let's take a look at another one. So here we're working with y equals x squared minus 4. And again, let's try working with the table of values. So we'll start plugging in our x values here. So y equals -2 squared minus 4. And that comes out to 0. Y equals -1 squared minus 4. That comes out to -3. Y equals 0 squared minus 4. So that's a -4. Y equals 1 squared minus 4. That equals -3. And then y equals 2 squared minus 4, and that equals 0. So let's go to our graph and we'll plot those points. And we have -2, 0. So there's that point. -1, -3. 0, -4. 1, -3. And then 2, 0. So let's try and sketch this in. And there's our parabola. Again, we can draw in our axis of symmetry. It knows you go right through the vertex. So it is x equals 0. And then maybe identify the vertex here. And the coordinates of that looks alike. It is 0, -4. So let's go ahead and fill in that information below. The axis of symmetry, that is x equals 0. The vertex is 0, -4. And then the x-intercepts, let's go back and take a look at where they are. The x-intercepts is where the graph crosses the x-axis. So it looks like here and here. And the values there look like they are -2 and +2. So I'm just going to write -2 and +2. Now, what's the difference between this quadratic relation and the parent function? It looks like this one is shifted down 4 units. Down 4 units. All right, moving right along. Let's do the same thing here, except now we're going to add 4. And maybe you can start to see the pattern here. But y is equal to -2 squared plus 4. It's going to give me 8. Y equals -1 squared plus 4. That's going to give me 5. Y equals 0 squared plus 4. It's going to give me 4. Y equals 1 squared plus 4. It's 5. And then y equals 2 squared plus 4, and that's 8. So let's go ahead and plot those points on our graph. And we start with the -2, +8. So there's 1 point. We have -1, +5. That goes right here. We have 0, 4 there. We have 1, 5. And then 2, 8. So that goes there. So here is our function. And we can label a couple of things. Again, the axis of symmetry goes right through the vertex. And here it is x equals 0. The vertex here is 0, 4. And let's go back and fill in some of our information. Axis of symmetry, x equals 0. The vertex is 0, 4. And the x-intercepts, if you notice on this quadratic, it never touches the x-axis here. So in this situation, we just say there are none. No x-intercepts. And so how do we describe this? This is a shift up 4 units. So if we use a table of values with this again, you can go ahead and do some of the substitution yourself. But when you do that, I'm going to fill in the numbers for you. You're going to get -3, -6, -7, -6, and -3. So let's plot those points on the graph and have -2, -3, -1, -6, 0, -7, +1, -6, +2, -3. Let's shift that up a little bit. And so our graph looks like that. Again, our axis of symmetry goes right through the middle. Still x equals 0. Then we have our vertex located right here. And the vertex is 0, -7. So let's do a better job here at the top of our graph, because when we go back down to the bottom here, we're going to have to estimate the x-intercepts. So for our axis of symmetry, it's still x equals 0. The vertex is at 0, -7. Now the x-intercepts, if you were to do this on something like Desmos, it'd be very accurate because I'm drawing it by hand. It looks a little off, but let's go take a look. They look like they're about -2.5 and maybe +2.5. So that's what I'm going to go down and write here. So -2.5 and +2.5. And so how do we describe this one? This one is a shift down 7 units. Now, we can do this another way. Let's say we're given a completed table of values, and this is our parent function. This is y equals x². And we want to fill in the second table of values here with the c that is equal to -1 right here. Now, how do we do that? What we do here is we take all the y1 values and we subtract c, and that's going to give us the y2 values. So in my first example, I'll use 4, and I'm going to subtract 1. So that equals 3. And there you go. Next, I'll use 1, and I'll subtract 1, and that'll give me 0. Moving down onto the second page, we have 0 minus 1. That gives me -1. And 1 minus 1 gives me 0. And 2 minus 1 gives me 1. Oh, sorry, messed that up. Let me just erase that. This was supposed to be 4 minus 1. And that gives me 3. Sorry about that. We'll do that again for a second example, but in this one, our value of c is 5. So again, how do we change that? We're going to take all our y1 values, and we're going to add 5. So we'll have 4 plus 5, 1 plus 5, 0 plus 5, 1 plus 5, and 4 plus 5. So we will end up with 9, 6, 5, 6, and 9. Now, where can you spot the vertex? That is always going to occur when our x values are 0. So for table 2, the vertex is going to be at 0, 5. We'll take a look at another example. This time c is -3. And so we will start with 4 minus 3, 1 minus 3, 0 minus 3. I'll fill that in here. 1, -2, -3. The next part of our table is down here. 1 minus 3, 4 minus 3. I'll have -2 and 1. Looking for the vertex again, that happens when our x value is 0, and that happens right here. So if I fill in for the vertex, it's going to be 0, -3. So let's summarize some of the things that we have learned today. So we're trying to put together now y equals ax plus c. And remember, if a is greater than 0, it causes a vertical stretch. If a is between 0 and 1, it causes a vertical compression. And if a is negative, it causes the parabola to flip upside down. Now for c, if c is positive, it's a shift up c units. So if it's positive, we're going to go upward. And if it's negative, we're going to shift down. So let's take a look at this and how we build on this. You can do this on Desmos, or you can do it. I'm going to try and do it by hand here, but you feel free to go ahead and do it on Desmos. We can fill in the table of values, and we've done this multiple times, so I'm sure you're getting good practice at this. For our parent function, y equals x squared, we have 4, 1, 0, 1, 4. And if we introduce an a of 2, we have to multiply all those values by 2. So we will have 8, 2, 0, 2, and 8. And then if we subtract a 5 at the end, we're going to have to subtract all of those values by 5. So 8 minus 5 will be 3, and 2 minus 5 will be -3. 0 minus 5 will be -5. 2 minus 5 is -3, and 8 minus 5 is +3. So we want to go ahead and graph all of these on the same set of axes so that we can see the difference in the transformations. Again, if you'll feel comfortable doing it here, you go ahead and do it by hand. But if you would like to do it on Desmos, go right ahead and then upload a picture of that to this document. So let's see how well I do here. I'm going to try and use different colors. So I will put the standard parabola in blue, and we will go with, there's our vertex, 1, 1, 2, 4, and mirror that onto the other side. And so we have our parent function. Okay, I'm going to change colors. Let's go with red. And I'm going to graph the next one. Actually, you know what? Let me label this. This is y equals x², the parent function. Let's go to the next one, which is going to be y equals 2x², and that is -2, +8, -1, 2, 0, 0, 1, 2, and 2, 8. So we multiplied by a factor of 2, which is greater than 1. That ends up with a vertical stretch. So we see that the parabola gets a little skinnier. So up here, this is y equals 2x². I'm going to change my colors, and now I'm going to add the next coordinates. And we have -2, 3, -2, 3. And then we have -1, -3. And we have 0, -5. And then 1, -3. And 2, 3 right here. So let's put these in. And this one is y equals 2x² minus 5. So you can see how the transformations build on each other. We started with the parent function, which is in blue. Then we multiplied by that a factor, which we had taken a look at in previous lessons. And a factor of 2 causes the parabola to get stretched vertically by a factor of 2. And then finally, we subtracted 5. So our C is a -5. And that shifted the whole parabola down 5 units, which is represented by the green. So I'm going to go ahead and fill in these table of values, and then I would like you to go ahead and you can redo these graphs again on a new set of axes, either in Desmos or by hand. But I'm going to help you out with the coordinates for each of these, a little bit different. So we are starting here with our parent function, y equals x². Then here our a is -1. And then over here, our a is -1 and our c is +6. So if I start with my original coordinates for the parent function, the y values are 4, 1, 0, 1, 4. And then if I go over to the next table of values, I'm going to have to multiply them by a, so they become negative. A is -1. So all of those values have to be multiplied by -1. And then as I move over, my C is +6. So I'm going to add 6 to each of these Y values in order to get to the third table. So I have 2. -1 + 6 is 5. 0 plus 6 is 6. Negative 1 plus 6 is 5. Negative 4 plus 6 is 2. So there you have the table of values for those three functions. Again, I'm going to let you go ahead and graph it either in Desmos or by hand and upload it to this document. And then I want to move along to a couple of other examples here. So I want you to be able to not only graph the difference in the functions, but also be able to describe the functions and how they've changed from the parent function to something new. So here I'm given y equals 3x² plus 1. So I'd like you to state the vertex, axis of symmetry, whether the parabola opens up or opens down. That means if it opens up or down, and the step pattern. But I don't want you to graph it. I just want you to be able to describe all of these things. All right, so let's identify a couple of things. We have an A of 3, and we have a C of 1. Let's write that off to the side. An A of 3 and a C of 1. So what does that result in? We have the A will be a vertical stretch. Actually, let's start with the vertex. Where's the vertex going to be? The vertex for these graphs are going to be at 0 and whatever the C value is, which is 1. So there's the vertex. The axis of symmetry for these graphs are all the same, and that happens at x equals 0. Because A is positive, this parabola is going to open up. And now let's describe some of the other transformations. Again, because A is 3, this graph is going to be stretched vertically by a factor of 3. And then since C is 1, it'll be shifted up 1 unit. Then let's take a look at the second example. In this case, A is negative 1/2, and the C is negative 3. So the vertex here, again, is 0C, and in this case, it's going to be 0, negative 3. My axis of symmetry for these types of graphs are always x equals 0. Here, my A is negative, and when A is negative, it means it's flipped upside down, and so this parabola is going to open down. But it's also a half. So this parabola is, let's say, flipped upside down. Because it's a half, it's going to be vertically compressed. So it's going to look wider. And then it's going to be shifted down 3 units because C is negative 3. Good. C you can try on your own. And here I want to start working with the graph of the function and then seeing if we can come up with the function. So state the quadratic function that matches the graph of each parabola. Let's see what we can determine here. I'll zoom in on the graph and we'll take a look at some of the characteristics. So we have a vertex here, it's blue, so I'm going to use red, of 0, 0. Then let's see what the first step is. If we step over 1, there's 1, the vertical goes up to 2. So my step here is actually 2. Remember the step function of the parent, the step pattern of the parent function is 1, 3, 5. But in this case, our first value, our first step is 2. So that can help us determine that the A in this case is actually 2. We can take the first step, which is 2, and divide it by the first step of the parent function, which is 1, and that's where we get A equals 2. Our vertex is at 0, 0. So in this case, 0 is C. And so when we write our function, it will be y equals 2x squared. Let's take a look at the other one. Zoom in. So we have a vertex here of 0, 3. And let's see what our step pattern is here. If we move over 1 unit, so that's here, then we go down 1 unit. So over here, so the vertex is 0, 3. We can see that the C value is, so if the vertex is at 0, 3, then the C value equals 3. And if I take a look at the step pattern again for the parent function, but the step pattern here for this function is -1, then we can determine that A is equal to -1. So if I put the A together with the C, my function will be y equals negative x squared plus 3. Let's take a look at another example. Let's zoom in here again. So we have a vertex here that looks like it is at 0, -3. And if we take a look at our step, if we go over 1, we seem to come down a half. So with this information, we can go back, and because our vertex is 0, -3, then our C value is -3. And because our step pattern goes from 1, 3, 5, which is from the parent function, this step pattern is -1/2. So that means the A is -1/2. So my function here is y equals -1/2 x squared minus 3. And we'll do one more example. Take a look at this last function. Zoom it in a little bit. We have a vertex here that looks like it is 0, -5. And then our step pattern, if we go over 1, we reach the graph let's say looks like 4, if I'm counting correctly. So since our vertex is at 0, -5, then the c value is -5 of our function. And since the step pattern here is 4, and the first step of the parent function is 1, then our a value is 4. So our function is going to be y equals 4x² minus 5. So in order to write a function in the form y equals ax² plus c, we need to be able to determine the a and the c. And if from a graph, if you can tell where the vertex is, then you can find the c. And then if you can see what the first step is in a step pattern, then you've determined what a is. Okay, that's all we have for this lesson. I'll see you next time.